Now that we have learned about algorithms in the last part, in this part we are going to focus on design and analysis of algorithms. Before we look into what design of algorithms and analysis of an algorithm mean, we have to know about certain features of an algorithm. Okay, so we'll first focus on those features, and next we'll try to find out what is designing and analysis of algorithms means. So the first thing that we need to know about algorithms are the characteristics of that of an algorithm. Okay, so the first point or the first characteristic that we must mention is the finiteness of an algorithm. It means that an algorithm must terminate after a finite number of steps. Okay, so an algorithm cannot run forever. Okay, so if an algorithm runs forever, it is probably not going to give you the expected output within reasonable time. Okay, but we want the result from an algorithm, right? We want the solution of a problem using an algorithm, right? So if it runs forever, it is not possible for that algorithm to give you a solution, right? So that's why finiteness is an important characteristic of an algorithm, that it should terminate after a finite number of steps. And the next characteristic that an algorithm should have is definiteness. Okay, it means that each instruction has to be clear and unambiguous. So there should not be any ambiguity in instructions. Like if I say bring me glasses, so you could understand from the context that I am asking for my spectacles, but the computer might get confused, like whether it is the spectacles or it is drinking glasses, right? So that this kind of ambiguity should not be there in an instruction. So each instruction of an algorithm should be clear and unambiguous. Input is our next characteristics. Generally, but not necessarily, an algorithm takes some input. Uh, for an algorithm to be generic, generally there has to be some input, right? But there are also some algorithms where input is not required. For example, if we have an algorithm just to print hello world, right? So that doesn't have any input. Every time you run it, it will give you the hello world or any welcome screen, right? So this kind of algorithm doesn't give take any input, and generally on fixed set it will work, right? uh, Next thing that we'll talk about, or the next characteristic that we'll talk about, is nothing but the output. Generally and necessarily, an algorithm produces some output. Okay, an algorithm has to produce some output irrespective of it has taken some input or not. Why? Because what is the objective of an algorithm, right? So the objective of an algorithm is to find out a solution of a problem using computer, right? So now if you are trying to find out the solution has to be given to you by the computer, right? Which is basically output of the algorithm, right? So generally and necessarily, an algorithm produces some output. Okay, now output does not always mean that it will show you something on the screen. Any state change of some thing can also be thought of as output as well. Okay, it means that suppose you have written a program where you change some value of a data structure. Okay, that I mean that algorithm change some value in some data structure, that can also be treated as a change of state. Okay, of that data structure, and can be treated as the output of that algorithm. Okay, so output doesn't always mean that it will show you something. It can be state change of something. Okay, and the final characteristics is nothing but the effectiveness. uh, Effectiveness means the sufficiently basic operations such that can be carried out using pen and paper within reasonable time. So the instruction that you are given in the algorithm has to be very basic, such that any person, any layman can carry those instruction using pen and paper. Okay, any person can see the algorithm, see the one step or see the steps of the algorithm, and do it with pen and paper. Okay, which we call basically dry run. So these are the characteristics that an algorithm should follow. Okay, so when we are going to design the algorithms, we have to keep these characteristics in mind while we are designing it. And there are some criteria of an algorithm. Okay, what are the criteria? Basically there are two criteria. First is correctness. Okay, an algorithm must be correct. Okay, so what does it mean? An algorithm is correct if for every possible input it holds with correct output. Okay, means you have designed an algorithm and there are possible inputs, uh, like for example, let us take an example. Suppose you have designed an algorithm for uh, finding out an factorial of a number. Okay, so for every possible input it should stop with correct output. Okay, now every possible input means it can start with minus infinity. I mean the range of the input should be minus infinity to plus infinity, right? So for every possible input it should halt with correct answer, right? So the every possible input is basically the set of you can say that set of inputs uh, that can be feed to the algorithms. Anyways, so correctness is the most important criteria, or it is an essential criterion, because an algorithm must always be correct. Okay, without the correctness of an algorithm, I mean it is of no use, right? Because we are designing an algorithm to solve a problem, right? Now after running the algorithm, if we found that the answer it is giving, the solution it is giving is not correct, it is of no use, right? So correctness of the algorithm is the topmost criteria of an algorithm. Okay, so you can understand why it is necessary. Suppose we have already talked about the road crossing algorithm, right? Now, if you think about what if the road crossing algorithm is wrong, right? So probably you have to say goodbye to the world, right? So that's why the correctness of an algorithm is very important. Okay, because that is what it is first expected from an algorithm. Next is the efficiency. Efficiency of an algorithm means the algorithm should halt within a reasonable time. Okay, so you have developed an algorithm that gives you the solution correctly, but not in a reasonable time. Will you use it? Probably no. I mean, probably if you have any other option where you have more efficient algorithm to solve the problem, you will choose the more efficient one, right? That is which is basically taking less time, right? So an algorithm should halt with reasonable amount of time. Okay, and this is an important criterion, not necessary criterion or not essential criterion. Why? Because there it may be possible that there are no efficient algorithm for a problem. Okay, there is, suppose there are only single algorithm to solve a problem, but which is not efficient. Then you have to rely on that. You can try to bring efficiency in that algorithm, but until and unless you bring that efficiency in that algorithm, you have to rely on the uh, inefficient algorithm. Okay, but obviously efficiency is an important criterion, but not as important as correctness is. Okay, correctness of an algorithm has always be the first priority or first criteria to be met. Okay, and second criteria that is to be met is that it has to be efficient, it has to be within reasonable time. Now if we take this example, you will understand that what if the Maggie cooking algorithm took 2 years in place of 2 minutes, right? So probably would never eat Maggie again, right? So that is what efficiency means. So you could understand from these two examples that correctness and efficiency are both very important criteria of an algorithm. Correctness being the topmost criteria, and efficiency probably the second topmost criteria in this scenario. Okay. So with this knowledge, we can now focus on design and analysis of algorithm. So there are two parts in this whole heading. The first is design of algorithm, and second part is analysis of algorithm. So design of algorithm means an appropriate designing technique or appropriate technique that are employed to develop an algorithm. Okay. Now there are various algorithm designing technique available already. They are like brute force, divide and conquer, backtracking, branch and bound, greedy, dynamic programming. So all these are designing technique, and we'll going to learn all of them one by one in our course curriculum. Uh, Next thing is about theory of algorithm. Uh, it is basically is not designing an algorithm. It is basically proving that whether an efficient algorithm can exist for a problem or not. Okay, so this theory of algorithm studies the existence or non-existence of an effective algorithm for a problem. Okay, we'll find eventually see that there are some problems for which we cannot have an efficient or effective algorithm that gives output in reasonable time. Okay, those kind of problems belongs to NP classes. What are these? What are those things we will learn in due course? Okay. So these are the design part, and in the analysis part, there are two important analyses that we have to do for algorithms. We have to first analyze whether the algorithm is correct or not, or correctness analysis. Okay. So as I told you, the first and foremost criteria of an algorithm is to be correct, right? So once you develop an algorithm, you have to find out whether your algorithm is correct for that problem or not. Okay, or there is some error in your algorithm. So that analysis you have to do, and how you can do, we'll see. Okay, and next thing you have to find out the or analyze the efficiency of an algorithm. Means how much time it can take for a set of for an instance of input. Okay, so if we run the algorithm, how much time it is going to take in worst case, or in best case, or in average case. So what those case means, we will eventually see. So the efficiency of algorithms generally means how much time and how much space the algorithm is going to take when it is being executed. Okay, so with this we come to the end of part 3, where we have discussed or about an design and analysis of algorithm, and in the next part, or part 4, we will basically focus on analysis of algorithm. We first do the analysis of algorithm first, and then we'll dive into the designing of algorithms, because after we design an algorithm, we have to analyze those algorithms, whether they are correct or how much time those algorithms are going to take. Okay, so that's why we have a dependency of analysis of algorithm while we are studying the designing of algorithm. Okay, so next part we'll see you with the analysis of algorithms.